Okay, let's go ahead and get started. My name's Thomas Dunn, and this is my cohort, Koushik Hajra. We are product engineers on the team that builds the ArcGIS Runtime SDK for Qt. A couple questions before we get started. How many of you are runtime users? That is, have you at least tried out runtime at least once? So we've got, quite a few. We've got about 10 of you there. That's good. How many have tried this particular SDK? Well, about 5 of you. Okay, good. And how many people have done any work besides those, well, I know it's those 5, other people that have used Qt, the Qt SDK, the Qt framework from the Qt company? How many other people have used that? So one other person that wasn't included in the first 5, right? So, okay, that gives you a pretty good idea that you're all here in the right place because this is an introductory session. So what we're going to show you today is we're going to show you how you can create a multi-platform native application as easily on multiple platforms as you can on a single platform. How you can add standard features to that app and just out of the box, out of the libraries to allow you to concentrate on what makes your app unique, and how to leverage ArcGIS platform's capabilities in your application that you write. You can do that right now, and you can do it today by jumping right in and downloading our no-cost SDK and the one from the Qt company, and I'll talk about the differences between the two in a moment. So this session will show you how you can build such an app. And right now I'm going to get it over to Koushik, and he's going to show you the app that we're going to be studying today in this session. Koushik?
Good afternoon, everybody. Thank you, Thomas. Let me quickly switch over. So this is an app that we built with one of our APIs. Pretty simple app. So to begin with, when the app starts, you get a map and box where you can look for a place. So let me search for Chicago. And then I want to search for a destination. Let me search for St. Louis. Okay, so I got my origin, I got my destination. Let me do some routing. Okay, that's my route. So a lot of times, you've seen lots of routing apps, and in routing, most of the times when you're going from place A to place B, you hit some impediments. Sometimes it's traffic, sometimes it's construction. So we thought we can add a little twist to it, and we can add weather. How can weather affect your travel? So we added weather as one of the impediments, and we add a weather layer. This is a service that's coming directly from NOAA. It's live weather. And to see what kind of weather it is, we added a legend that shows what kind of weather it is. And today, we are going to show you how to build this app in a step-by-step process. So, and don't worry if you don't follow the code very much, because we're going to give it out to you anyways. So, but I'll tell you the concepts that we used to build this. With that, back to you, Thomas. But before I move it over, I just want to show you that we have the same app running on the iPad. It's that exact same app that I just showed you.
And by exact same app, you mean the same code?
Exact same code that's running, yes.
Okay, so it seems on the surface like a fairly straightforward, simple app, but there's a lot going on in this app, isn't there?
Yes.
There is geocoding, there is routing, there are getting weather services and getting features from a weather service, there's getting a tiled map layer for the base map. There's doing, you'll see some other things in here, like how we built the legend and how to do geographic intersections and all sorts of things. So this app, as we walk through it, you're going to see a lot of the capabilities, some of the really basic capabilities that are in the runtime that you can use to build your own applications. Also, and we'll get into samples too, where you can get some more ideas about this. So our agenda for today is to talk about 2 software products that you're going to be using when you write your applications. The first is the Qt framework from the Qt company, and the second is ours, ArcGIS Runtime SDK for Qt from Esri. We're going to show you a couple of app design patterns. There's a couple of different ways that you can engineer an app like this, and it depends on what you're comfortable with, or the way you'd like your app to perform, or the types of features you want to include in your app, and you can make choices about that. And I'm also going to spend some time showing you the website and other resources for developers, so you can reach out to others, and you can also see the wealth of information we have out there to support developers. So this is an intro level session. If you've had some exposure to this, you're probably going to get some new information out of this session. But if you haven't had any background in runtime yet, or if you haven't had any background in Qt, that's okay. You'll be fine in this session. So what is this Qt thing? A lot of people call it Qt, by the way. My feeling about it is, as I said, the guy who invented it, wrote it, calls it Qt. He's a guy from Norway? Is that where he's from?
Thanks.
Yeah. So this was created to build cross-platform applications. That's what it's for. And it provides high-level abstractions to language constructs that you need if you want to write an application in a generic way so it will run on multiple platforms. Take, for example, something as easy as a string. A string on .NET is way different than it is in C, which is way different than it can be in other languages as well. So it provides a QString construct, which is a class which underneath, it's really a meta class because when it gets compiled down to what is appropriate for the particular operating system that you're working on. There's also more sophisticated things like, is there a camera on the device? And how do I get to that camera? Well, there's an abstract class about a camera that lets you go and access the camera in a platform independent way and work with that camera, and then that same code will work across different operating systems. So the upshot is you don't have to be an Android developer to develop for Android. You don't have to be an iOS developer to develop for iOS. If you can write your code in Windows or Linux or Mac OS and then just recompile it and export it to the device, and now it's running on Android and iOS. It's pretty much that easy. Yeah, people say it should just work, it's supposed to be perfect. And nothing is exactly perfect, but when things are set up properly in your environment, it truly is as easy as run it on your Windows box, flip a switch, run it on your Android device. It just really is that easy. Now, the Qt company is not a young thing. It's been around for about 20 years doing cross-platform development. That's what they did. They got their start early on, and they worked with Nokia, and they were trying to build a system to build UI for different types of phones and that sort of thing, and do it in a platform agnostic way so that they could write one set of code and run it on all these different devices. So with their framework, as I mentioned, you write your code once and you run it on any of their devices that are supported. Their latest version of framework was downloaded about 1 million times, and there's about 800,000 developers that are using this throughout the world in many different industries. There's also an open source community. That's because it can be licensed both commercially or open source. So this is a mature and proven tool, and it's been shown that it can reduce the amount of time to get a multi-platform application out by as much as 50%. So it's very powerful. Now, Qt Creator is the IDE, and it comes along with the Qt framework. The great thing about the Qt Creator IDE is it runs on Linux, Mac OS, or Windows with very much the same user experience. The menus are slightly different because they try to make the menus for Mac look like one for a Mac and one for Windows look like one for Windows. You would expect, for example, to find the About button in one place on Mac and another on Windows. But besides those very small variations, the same capabilities are available whether you're running on Linux, Mac OS, or Windows. All right, now let's look at our product. This is Esri's product, ArcGIS Runtime for Qt. Now, Runtime itself was created so that you can build GIS applications that perform really well, because Runtime apps run natively on whatever device they're running on. And by natively, I mean they're compiled all the way down to machine code, down to the metal, I like to call it. This is not an emulation. This is not a virtual machine. This is not HTML. This is actually an application that's built all the way down to machine code on the device. So through Runtime, you can leverage ArcGIS power. So you can do services for data management. You can access those. You can access REST-based data and analysis services. And of course, you can do on-device processing. There's a lot of processing you can do directly on the device, which is quite powerful. Now, there are several sessions, as you've seen on the schedule, about runtime. One thing you may notice is that there's a lot of them that don't say for Qt or for .NET or for iOS, and that's because the technology that underlies it all, Runtime Core, is the same core underneath all of our SDKs. So the advantage is you can learn the fundamentals of how runtime works and apply that regardless of which SDK you're using. You might choose to use the Qt SDK, you might choose the iOS SDK. They each have their advantages and their place in the world, but the functionality is the same across all of these. So I encourage you to go find some of these sessions, sessions about runtime in general. The ones I particularly think you should look at if you haven't had a chance to is an introduction to the API and architecture. So that'll give you a good starting place for runtime. The one on building 3D applications is very good. That's the one on the bottom of the list here. And also one I think is really important and sometimes not as much time might be spent on it is building great user experiences. How do you develop a UI that is intuitive and is useful to your users in their given situation? So when should you consider using the Runtime SDK for Qt? If you're building applications and you want it to run on more than one operating system, if you're using, for example, the runtime for iOS, it runs on iOS. That's what it does. If you want to use the same code and the same workflow across whatever device you happen to be using. When you want to access the device's sensors, as I mentioned earlier, getting to the camera or getting to the compass or getting to a network connection is abstract and it's the same on all those devices. So you don't need to worry about the details of how to get to a camera on a iOS device. And there's also a vibrant open source community. A lot of people in the Qt ecosystem that have been for years working together to build great applications for their customers. Another thing to consider is, do you already have in-house experience in JavaScript or C++, or even QML and the Qt framework itself? Those are good reasons to start looking at ours as well. When you're ready to start writing some code, here's how you get started. Install the Qt framework from the Qt company. It's free to download. Just download it and start using it for development purposes. Log into ArcGIS Online with your developer subscription and download our Runtime SDK for Qt. It's also free to download for developers' purposes. You can access all the functionality inside of ArcGIS Runtime. Install any supporting software you need. For example, if you're going to be developing for Android platforms, there are some Android libraries and things that need to be downloaded and installed on your system. And finally, run the installer and the post installer, as you would have to do with any product. I want to take a couple of minutes here and go through our website, developers.arcgis.com. I'm going to pop out of the session for just a moment and go to my website and show you some important things you're going to need to know as you start using our product. The first thing to think about is signing in. There is a no-cost developer subscription that you just go in and sign up for, and once you have that, you can log into the system and download the software. Here's where you download the software. It's available for download for Windows, Linux, and Mac OS. Why not iOS and Android? Because these are the developer platforms. You write code on one of these platforms, and then you build it for Android and iOS, depending on which platform you're working on. If you want to know what it takes to actually install the SDK, these are quick links to the installation instructions, which are in the guide. This also lists I mentioned there might be some other files you need to download, like for Android development. This will list what all of those things are. Are you looking at the right version? This, version 100, is our latest version. It's what used to be called Quartz. So if you've heard Quartz being talked about, that's version 100. But version 10.2.6 is also still in the field, and a lot of people are still using that. How many people are using Runtime for Qt right now? I forgot that number. How many were there? And of you, how many are using version 100 yet? Okay, good. A couple of you have moved on to version 100. That's good news, about half of you. If you aren't using a 100 yet, you can go to the previous version by clicking here, and it'll take you to another web page which looks pretty much like this one, except it's all about 10.2.6. Not sure which one you want to use? Click on this link, choosing the right platform, and that will help you make a decision about which one you should go with. We, of course, would like you to use the most up-to-date one, but there might be other reasons why you may or may not want to do that, and this topic talks about those issues. As far as seeing what Runtime is all about, probably the best place to really dig into it is in the guide. And the guide is on the second tab of this page. Particularly, besides the install stuff, which I mentioned before, there's this fundamentals section, and it gives you the big picture topics of how Runtime works. These are some of the things that would have been covered in that initial introduction to Runtime session. So this talks about how maps work and how layers work and what scenes are and all of those things. Then there's the samples. We have a large number of samples. And if you're writing something, it's likely that at least part of what you're doing is already in a sample someplace that you can borrow. Now, there's a number of ways to get to samples. One is you can download the samples viewer. And the samples viewer is in ArcGIS Online, so you can download that. Basically, when you click on that link, it does a search in ArcGIS Online and lets you download samples viewers. So for the samples that are listed on the website, those samples are in a single application that you can run and then click through the samples and try each of them out. Also, if you go to individual sample here, it gives you a description of what it is, how it works, what the main features are, the code, at least the main part of the code. If you want the entire project, go to GitHub, and we have it out on GitHub. Here's the entire project with all the files. You can download it, put it into Qt Creator, and build it and run it and modify it as you will. So our samples are easy to get to, they're easy to study, they're easy to take things out of and use. Let's go back to the website for one more thing, and that's the API reference. Our API reference is actually 4 references. The 2 big ones at the top here are the C++ reference and the QML reference. Both of these APIs contain the functionality of runtime. That is, that's where you're going to find maps, that's where you're going to find services, that's where you're going to find all the pieces that make up the runtime API. And they are in C++ and they're available in QML. We'll see more about those in a moment. We also have a couple of smaller APIs at the bottom. The Toolkit API is useful. There are a number of places where you might do a request against a service and get data back, and data will come back in a data model. And if you want to easily display those things in your UI, we provide capabilities for that in this toolkit. You can also create your own UI and do what you like, but this helps you if you're just trying to get started getting some data up on the screen. The QML Extras API reference is for things that we thought they should have put in the QML API, but they didn't. And things like, how do I create a new file? How do I get to the header information inside of an image file? That sort of stuff. So there are extensions, if you will, of us to the more general QML API from the Qt company. And finally, I want to mention the forum. The forum is where you can get questions answered from each other, from engineers, and to find out if your question's already been answered. It's a really good place to share ideas and share information. All right, now we're going to talk about the app patterns. Remember I mentioned that you had some choices when you start building a runtime application. And those choices have to do with, there's actually 3 different patterns you use, and I'm going to show you them right now. The first one, let's talk about, actually the first 2 are using the C++ API. Now I mentioned that we have these 2 large APIs, one for C++ and one for QML. And they all have all of the classes in them that it takes to get to the functionality within runtime. When we get to the demo in a minute, you're going to see some of that functionality. But the other choice you have is, what do you want to use for a user interface? You can use Qt widgets, which is, I would call it legacy at this point. Their way of displaying a UI on the screen. And then there is Qt Quick. And Qt Quick has a number of advantages over Qt widgets. For one thing, it runs on all 5 of our platforms, and the widgets only works on our desktop platforms. It provides things like animation, support for animations of like particles and fades and all sorts of things. It's quite an amazing language. So, and the other thing to think about is if you're going to be using local server, you need to use a C++ API. Now, some of you might be using local server I don't know if you're familiar with local server from 10.2.6, but local server is a product that lets you do some things outside the world of runtime and be able to host services locally for things like map services and geocoding and things like that. And if you're going to be using local server, then you'll need to use a C++ API. But as far as the UI goes, we really recommend that you use Qt Quick and QML for UI development. So we're going to talk about that in this session. If you want to learn more about Qt widgets And whether that's something appropriate for you, come see us at the showcase afterwards. All right, so as I mentioned, you can use the C++ API for your backend, and you can use Qt for your user interface. And we're going to see that done now in our sample application. Over to you, Koushik.
Thank you, Thomas. Okay, so we already saw the app, how it runs. Let's quickly see one more time what we have when the app starts up. So we have a map, which is a base map here. And we have a text box where you can start typing for an address or a place. So as I start typing, you get a suggestion, which is something new that we have in this release. So, and once I got a suggestion and I clicked on one of the items that I wanted, it added a graphics on a graphics layer. So let's see how we did that in code. So as Thomas mentioned, we have 3 paradigms of starting an application, right? So once we open Qt Creator, you've done the installation and uninstallation. We go to file, run the post installer. You go to file and click new. We install 3 different templates. One of them, this is where you create your application with C++ and your UI is widgets. The second one is you still create your backend code with C++, but your UI is with Qt, which is QML. And the third one, where your UI is with QML, your logical code is in JavaScript, it is a purely QML application. So I know a lot of our users have asked for the second paradigm where you want to create your backend code with C++ and your front end with Qt, and we did listen to you. So we have added that support. So let's use that, and I'm just going to create a very basic application to start with. Let's get a map up and running. So I want to create a 2D app, so I'm not checking this 3D button here. And I'm just going to select whatever my base map, the default base map, just going to select all the defaults here. And this is where it asks me to select what kit I want to select. So basically a kit is, in this case, the compiler and my target platform. So here I'm targeting desktop because I'm running it on a Mac, and my compiler is Clang. Once I move ahead, it creates the project for me. And if you look in the projects view, if you look under sources, it added a class, a C++ class called untitled, because that's what I had named. I didn't name my class anything better than that. So this class is being exported to QML as a type. And when we go to our QML, you can see I'm importing that class here, and I'm using that type as a QML component. Let's quickly take a look at the C++ code. So this is where I'm creating a map view, and this is all done for you. You don't need to do anything. And this is where the map is getting created and a base map is getting added. So we had seen that it's the base map, in this case, is topographic, which is what the default is. I want to change it to something else. Let's say I want the streets vector base map. So we have added these static classes, which are really handy. You don't need to remember any URLs or anything. So it's that easy. I just selected streets vector, and now if I run my app, I just change it to release because release is just a little faster. Now if I run it, once it builds, I get a vector base map with streets. It's that easy. Now, this is a UI that's built with Qt, right? So it should be very easy to add Qt items. So let's see if we can quickly add a Qt item onto my application. So I can very easily add a button here. And I'm going to anchor it. I'm going to anchor it to the top left. So I just call parent.top, and my left is parent.left. And now if I run it, there's my button. So I could switch this button out with a text box or something, or whatever component I needed. So it was that easy to add any Qt quick item. So I'm going to close this application. I'm going to go back to my demo. So here, that's what you saw. So this was the base map that I had added. And this is my text box that I was using to search. So in my code, when I look at it, this is the text field that I added. And the way I was getting a suggestion is as you start typing, the text on the text box is changing. It's bound to a property in my C++ class called search text. So the moment I start typing, the text is changing. It's notifying the class in the back end saying, hey, your text is changing. And that in turn causes another notification to a list model. And that list model result changes. So what you get here, so let's say if I search for St. Louis, so this is a list view that's tied to that same list model. So the text box, as I start typing, it notifies the search text saying the search text is changing. Based on that search text, is the list model is changing, and because the model is tied to this view, the view is changing. So in code, this is where I bind the text. So on text change of the text field, I bind it to the search text property in my C++ class. And where is my list view? This is the list view in my QML code. So this is all still QML. I'm not showing any C++ yet. I'm going to go to that code in a minute. So the most important thing about this list view is the model. This is where it's tied to the model in the back end. So I have a list model called suggestions, origin suggestions basically, and that's the model it's tied to. And the other important thing about a list view is a delegate, which is how I want to define each item in the list view. And guess what happened, right? When I typed, as I started typing, I'm getting my suggestions. But the moment I click on it, it does the geocoding for me and adds a graphic, which means there has to be somewhere there has to be an on-click event. So let's quickly take a look. Where was that done? So here is my delegate. So each item is defined by this delegate. So the delegate is nothing but just a rectangle with a text, which is the text that comes with each of the names. And there is a mouse area on top of that. That's where I clicked. So what happened when I clicked? Let's expand that. And it called a function. I'm doing some UI stuff just to clean things up. And it calls a JavaScript function here. I'm still doing everything in QML here. And in this function, again, I'm setting some Boolean values in my UI just to hide and show things. But this is the important code. So I'm calling a C++ function in the back end. So let's now take a look at my C++ code to see how I did all of that. So that means I had a locator somewhere, which, and this is where I initialized the locator task. So I created a locator task, and I initialized with the URL, and I call load on it. You don't have to explicitly call load. The moment you call geocode on it, it'll start the load cycle. But I just did it just to have everything ready by the time I get there. So I did connect up some signals. Load is an asynchronous process, and it emits a signal called load status changed. So every time the load status changes, it emits a signal. I want to connect to that signal to know when my loading is done. So once the loading is done, so I just check the status every single time. Once it's loaded, I initialize the suggestions list model. This is my list model. And this is where I initialize the list, right? Every time my text changes, I'll show you where that search text property is in a minute. The search text changes, and that initializes this list model too. Like, so once the search is done, this is the list model that'll get populated with all the results. But this is where it's getting initialized. And then I emit a couple of signals, and this is where, because of these signals, the whole notification system works. Okay, let's see where the geocoding was done. So I have a geocode function here, and this is just one line of code. I have a locator task, I just call geocode on it with the address that was there in my search text box. So again, geocode is an asynchronous process. So I did hook up with when I wanted to know when it was done so that I can add the graphic to my graphics view, right? So this is where I hooked up my geocode completed signal. And once it's complete, I just get the results. If I did actually get a valid result, if it's greater than 0, I get the result at the first index. And then I cache a couple of things. I cache my origin point, which is the geometry of that point that I got. And I create a graphic out of that, and I add that graphic to a graphics overlay. And I also zoom my map view to the extent, because the result gives me an extent. So I use that extent to zoom to that view. So it's that simple. With the API, we have provided you all the mechanisms. There's not much code that I had to write. We give you the list model. All you have to do is just hook things up, and everything just works. So we have done all that hard work in the back end. So now if I quickly switch over to my header file. So these are the couple of list models that I have. Now the reason I have two here is one is for the origin text and one was for the destination. That's why I have two locator tasks, two list models, two of everything. The other thing that I wanted to show you is the search text property. This is my search text property. So this is a property, and the moment I start typing, because it's bound to the text box, this is what it changes. And it emits a signal, the text has changed, and that causes this list model to the result to change, and that's how it all works. Sounds good? Any questions so far? Okay, so once we're done with that, I click on the route button, and that does the routing for me. So again, we follow the same paradigm. So what we've done is I have cached these points. Remember, like from once the geocoding was done, I was caching these points. The reason I was doing that is I have a route task, and I was creating my stops based on those points, and I use those stops to generate my route for the route task. I just call route on my route task and generate my route. So we are using the same paradigm of list models and list views. So here again in the UI, I have a list view for all the step-by-step directions, and in the back-end, route task has a property, has a list view, and I'm just tying it to that. Just for the sake of time, I'm not going to show you because it's a very similar thing. But let's move on to this thing where we turn on the weather. How did we get the weather? So the weather is actually a feature layer, and we got that as a service from NOAA. So if I go back to my component complete, or actually my initialize, I created a service feature table, which is the table for the feature layer, and I used the URL from NOAA to create a service feature table. And I used that service feature table to create a feature layer, and then I just added it to the map. Just 3 lines of code, that's all I needed. And what I had done is I had done this in the initialize function because I wanted to have it ready by the time I need to use it so that it doesn't take time to load because it's a service that's outside of my control. And I just set the visibility of it to false. So every time you turn that slider on, so I have a function called add feature layer, I just set its visibility to true or false depending on what the value of the slider was. So I'm just binding it to the value of the slider. Okay, so that's how I got my feature layer. So these are the weather layers. So now, how do I know what kind of weather it is? I use a legend. So again, we're using the same paradigm. The legend is again a list view, and in the back end, it's tied to a list model. How do we get the list model? So if you go back to the map, map has a property called set auto fetch legend infos, and it just takes a boolean. So I set the boolean to true because I want all my legends. And this emits a signal again because it's an asynchronous process. If I go to my connect signals method again, I have connected up the map legend infos to fetch legend infos completed. So basically, once this is completed, I am binding this legend infos, which is a list model, to my list model, and I emit this signal. So because I'm binding it and I'm emitting a signal, the moment it changes, the value will be automatically populated the moment I load that layer, and it's bound to my list view, so I will automatically get the results as it's populated. It's that simple. And the way I decorated, like I defined my my legend in QML is, here is my legend, the entire legend. So it's just a rectangle with some behavior on height. That was just to do the animation, a mouse area where you click, and here is a column, and this is my list view. And it's got a delegate, and the list view is tied to the model. That was the C++ model I just showed you. So that's how I get the legend. Now there is one more cool thing that I added. So just to show the power of these, how much work we have put into it, how much powerful these list views are. So if I click on, say like you can do n number of things with these list views, but what I did in this case, like say you want to know where exactly this segment falls. So I click on it, and it highlights this part of the route, and it just highlights this part of the route. So all I had to do is I just had to get the index, what index I clicked on, because I knew this is a list view. Every item is indexed, and I got the geometry of that route, of that segment, and I zoomed my map view to that geometry, to that extent, and I just added a new graphic using that geometry, and I just added on top of it. All right, so that was the demo that I created with C++ being the backend and QML as the front end. So it's very little code that I had to write. Most of my code was just hooking up QML stuff, building your UI with QML. So I'm going to show you a very similar demo in a few more minutes that's built with QML. With that, back to you, Thomas.
Okay, thanks. So one of the things I want to highlight from what Koushik just said was that the work of actually doing the geoprocessing that it takes to get the things up on the screen, to display the map, to do the geocoding, to do the routing and all that, was handled in C++ code, in the back end, if you will. And the management of the user experience, that is how things appeared on the screen and what buttons did and what they called, was controlled by the QML side of it. And this is a common practice for people that develop Qt applications. They divide that up, the view portion of it, from the back end. So in QML, though, which you saw QML in this example. So it's a declarative language, as he showed. You declare types and you declare things within types. And you declare these components very similar to the way you would write Java, JSON or CSS. And when you saw bits of procedural code that were written on the QML side, they were written in JavaScript. They're actually running on a JavaScript engine. So this lets you create a UI pretty rapidly and provides the capability of doing animations like when you see the thing slide in from the side and all of that. That's all part of the QML UI library. So in addition to using it for just UI, we've extended QML by adding our runtime as another set of components. So all of those classes that you saw in the C++ code, things like map views and maps, are all also implemented in QML, so you can write the same application without any C++ code, without writing any C++ code. Now, one thing I want to mention before we get back into that example is there's this idea of default properties. I'll mention default properties as we go along. What a default property is say I create a rectangle. Oh, no, say I create a, let me try this again. Say I create a map view. The map view is going to create a map. So if I declare something that has a type of map, it will automatically get set to the map property of the map view because I didn't tell it to set it to any other property and because the type is map. So it just knows, okay, here's a map, I guess it's the map, and it applies it. The same sort of thing with like a feature layer. If I add a layer to a map, it will say, oh, he wants to add this layer to the map. I'm going to add it to the list of layers. And I can create another one. It'll add that to the list of layers. There's a behavior, and the behavior is based upon the data type of the component that we're installing. So you're going to see how that is used to cut down even more on the amount of code required when you build things in QML. All right, back over to you, Koushik.
Thank you. So this time, I'm going to create the same app, but with QML. This is completely with QML, but guess what? I could take a lot of the QML code that I already had. I could use it here, like my delegates, my list views, and I could still use them here. So instead of binding to a C++ model, I would just bind to the model in the QML objects model. So here is my map view in this case, and to my map view, Thomas was just talking about default properties. So what I did is I added a few default properties to my map view because I already know that graphics overlay, which is like a graphics layer, is a default property for map view. So I just added a graphics overlay, and within graphics overlay, I added graphics like my origin graphic, my destination graphic. And within graphic, again, I added a default property for symbol because I already know what kind of symbol I want for my graphics. So I've already done all of this work. And when I created the graphic, all I had to do is I just did not add any geometry. So when I actually do my geocoding, I just take this graphic and I assign it a geometry. So next time I say I want to change the geometry, all I have to do is say origin graphic.geometry equals whatever the new geometry is. And the graphic just keeps moving around in the map wherever I point it to. So I don't need to recreate the graphic every single time. It's already done for me. I just change the geometry of it. So these cool default properties are really cool in that way. Like you don't have to write a lot of code. So this is where I created my map view, my graphics overlay. Now, here is my locator task. Just like C++, this is the locator task in QML also has a list model, and it's called suggestions. And I'm tying it, the locator task, when I show you the delegate or the list view, you'll see that it's tied to this locator tasks suggestions, which is its list model. So, just like C++, I have tied all of these things together and everything works exactly the same. So when I go here, I start looking for St. Louis. Sure enough, it works. And when I search for Chicago, yeah. Oh, what happened there? Clear everything up. Oh yeah, it's just hiding right here. I have to add a buffer. Right there. And then when I do my routing again, where did it go? Oh, right there. So let's see how it worked in QML. There is my list view that I use for my suggestions. And in this case, my model is the locator task that I just showed you at locator task suggestions. And I am using the exact same delegate that I used in my C++ class. If I show you the code, it's going to look very familiar. Except in the onClicked, I still use the same function, but I called the QML object locator tasks.geocode and not a C++ class in this case. It's because QML exposes the exact same functionality as C++. Okay, so once the geocode was completed, so I have hooked up to that same signal. So once geocode status changes here, again, I'm hooking up to that signal. And once the task is complete, I get the result at location 0. I get I cache my point and my extent. And remember what I had said? All I'm doing here in this case is I'm just setting the graphic, the geometry for the graphic, and the graphic just appears in that location. And I am setting the map view's extent to that. So similarly, I have my route task defined here, and I have a couple of stops that I've pre-created, and I'm binding the geometry of the stop to my origin point, which is the point that I find from my geocoding. So because I'm caching it every single time I look for a different location, my stop is automatically updated. So it's all bound together. I'm not having to write anything else because it's already property bound. So when I go to my route task, I don't have to create my stops or anything. So when I click on the button called route, I just called route task.route with a list of these stops. And how do I add these stops to the list? I already created this on component completed. I'm pushing it to a list. So it's always pushed to a list, and the geometry, the stops are constantly changing the moment I change I find a new location. So then I can call my route task, and once the route is done, once the solved route status changes, once it's completed, I get my generated route, I get my route geometry, I set my directions, and this is again a list model. The directions in the generated route, the direction maneuvers is a list model, and that's tied to a list view here, which is this view. And that's how I automatically get the list view. Now, same thing here. I have the weather. How did I add the weather layer? So if I switch to my map, I have a feature layer. And within a feature layer, service feature table is a default property because every feature layer needs some kind of a table. So because it's a service, I'm using a service feature table. If it was local, I would have used a geodatabase feature table. So I gave it a URL, and that was it. That was all the code that I needed. And I set the visibility to false, just like I did in C++. And every time I switch the slider, I just change the visibility of it. The layer is already there. I just switch the visibility. Okay. Now, how did I get the legend? Just like C++ here. So just to show you, that was my legend again. So it's very similar. But before I go down, I want to show you that map has a property called auto fetch legends. And I'm just setting that property to true. And in my legend below, where I'm creating the legend, this is the list view. And here is where I'm binding the model of the list view to the legend, maps legend infos, which is again a list model. And the delegate again is the exact same delegate that I used in my C++, in the case of the C++ app. So in QML, I tried to do something fun, and let's see how long it takes. So you can do a ton of different things, but I wanted to see how weather is affected, which parts of my route are getting affected by weather. So what I did is I just clicked on it. If I click on it, it might take a little bit to process. So what it does is it queries the feature layer for all the polygons, and once it's done querying, I get a geometry from all those polygons, and I intersect that with my route geometry, and I draw a new graphic on top of it. So hopefully soon I should see a red graphic along the intersection of the weather. So you might not see it here, you might see it here. It takes a little bit because there's quite a bit of processing here. So I'll show you too when it's done, and Thomas can continue.
Okay, thanks. I was looking at those polygons, by the way, online last night at the NOAA site. They are extremely dense. You get down, and some of the points are like 150 feet apart.
Yeah, that's why
and
it
these
takes,
things are
because they're
counties large. It's quite dense data. So these are the three models we talked about. The one in the middle, the C++ using Qt in the background, is very popular for people that have a lot of heavy lifting to do in code. If you're going to be writing JavaScript code, which takes a little bit longer to run than compile to the metal C++, if there's a lot of procedural code, you might want to go with the C++ with the QML front end. And if you don't have a lot of procedural code, but you're doing a lot of wiring things together like we did in this application, then using QML by itself is also a fine way to go. So the Qt framework from the Qt company is licensed. There are a couple of different ways you can license the Qt framework. And you can find this on qt.io/licensing. And there are two main types, and the one that applies for most application development is the Qt for Application Development license mode. That's easy to remember. There's also one for creating devices, for example, when you're creating in-vehicle embedded systems and that sort of thing. Now, Qt is dual licensed under both commercial and open source licenses. And so for details, go look at the Qt site for information about this. ArcGIS Runtime SDK, version 100 licensing, has a license model with various levels of increasing access to more sophisticated functions. If you have questions about runtime licensing that you haven't got answered in another session, come over to the showcase and see us, and we'll put you in touch with someone who can give you details about our licensing model. So, we hope you find this something that's worth your time to go and download. Remember, the downloads are no cost. You can go get the Qt framework, you can go get the Runtime SDK, bring them onto your system, set them up, and have fun building runtime applications from simple to complex. Log on to ArcGIS Online with your developer account. You probably have one already if you've been using developer APIs. If not, it's easy to sign up for one. Download the things that you need to download and do some reading. I mentioned in the guide that there's a section called Fundamentals. I would take a little while and sit down and read through those fundamental topics to give you an overview. The more you know about how runtime fits together, the more enjoyable and successful your experience is going to be using the SDK. And then study some of the samples that are interesting to you. If you see something that you might want to include in your own application, go to GitHub, look at those samples, bring them down, build them, play with them, and understand how they work. And that's going to help you a lot. And finally, I really encourage you to use the forum, because there's a lot of people out there doing what you're trying to do right now, and you can help each other out there. Also, for those of you that are interested in App Studio is a product from Esri that was built on top of this SDK, and it provides configurable applications where people can add their own content to applications, modify them, and build them for multiple platforms. So there are several sessions about App Studio coming up. There's two this afternoon. One's in Primrose A, developing cross-platform native apps. And there's another one right after that. And then tomorrow there are two demo theaters about App Studio. So if you're interested, please have a look at those. All right, please give us your feedback. Thanks for attending today. All the feedback we get back from these sessions, every bit of it is read, and we use all of it to improve our sessions. So thank you very much for attending, and we'll take questions.
Here is, it did come back.
Okay, good.
And I just wanted to quickly show that. It took a couple of minutes, but it did come back.
We'll have to figure out why.
Well, it's just because there are too many polygons. Too many of them. It's quite a long route, so.
Mm-hmm. Questions? All right, thanks for coming.